I want to produce a cloud for you. So what we need is the atmosphere, we have the air in here, and then we need water vapor. There is already some water vapor here in the air. Relative humidity in here is not so high, but what is more important also, the absolute concentration of water vapor is at the room temperature here not very high. So I'm going to use warm water. So with that I can achieve a much higher absolute concentration of water vapor because of the much higher equilibrium vapor pressure over warm water compared to cold water. So then I need a container for my water. In a normal atmosphere that could be the ocean or a lake. Here I will be using a bottle. So I produce a cloud in this bottle. Let's fill in some water. Steaming hot water. Now I can close this atmosphere, and in this way, just by waiting a little bit, I can reach 100% relative humidity inside the bottle. After a short while, the water vapor will come into equilibrium with this hot water, so 100% relative humidity. There's always a little bit of condensation on the wall, which I don't want. I want the cloud inside the bottle. So now we have 100% relative humidity, but we need actually a little bit more. So how can I achieve supersaturation in the bottle? By cooling the air inside the bottle a little bit. And that I can do by adiabatic expansion. So if you do a quick expansion, the air will cool, and I can achieve that by first compressing. And if I compress and wait a little bit, relative humidity will be 100%. If I then let go, the adiabatic expansion will cool the air and generate supersaturation. I'll get rid of condensation and I let go. No cloud. Maybe we can zoom in a little bit. So I'll try one more time. I compress, get rid of condensation, and no cloud. There's something missing here. We need condensation nuclei, cloud condensation nuclei, CCN. Small aerosol particles where water vapor can condensate on. There are a few CCN here in the air. There's always a little bit of aerosol, but only at a concentration of a few per cubic centimeter. And a few droplets per cubic centimeter, that is not enough for you to see. So I will put in some more CCN in the bottle. For that I will burn a match. And then put the smoke in the bottle. Now there are a few million CCN particles in the bottle. So I can close the atmosphere again. Get rid of condensation on the wall. Compress. Get rid of condensation again. And if I let go now, very weak cloud. Maybe not enough CCN. Or I I didn't compress enough. Let's see. Compress and adiabatic expansion. Now we have a cloud. I can make this cloud disappear by compressing, that is warming. Well, actually there's also some condensation on the wall. And then I make the cloud appear again. Disappear. Appear. And that is how you make a cloud in a bottle. And we can cloud in a bottle disappear.